Just again, I apologize. I know some of you have heard this, but maybe not everyone has. For a few scheduling updates, we're still an hour behind in this room. We'll remain an hour behind. And then at 1 a.m., there will be a few films in here, and we're still actually getting the full details on the films, but they're films that you probably haven't seen before. That'll be pretty interesting, hacker, history, culture types of things. That'll be 1 a.m. Robert Steele is going to start at midnight, not in this room where he was scheduled, but in the next room, in the Tesla room. And the only other change to this hour off thing in the Bell room, the smaller room back there, is that the telephone folks are just starting up right now, so we moved them to after the social engineering, and everyone else will remain an hour behind schedule there. And I wrote this down, it's on a sheet of paper on the glass case out there. We have a concert starting up, which you're going to plug as well, starting at 11:30 down in 11:30ish anyway, down in the mezzanine. If you checked out last night's concert, you know you want to check out tonight's concert. It was really good stuff. So you have basically 3, 4, 5 places to be for at least the next 3 or 4 or 5 hours on the conference floor up on 18 and down on the second floor. I think those are the program updates, and so let's go ahead and get started with our next talk. This is Circuitbending with Jimmie Rodgers.
So, hoopla, everybody. So I'm Jimmie Rodgers, and I've got a lot of stuff to cover in a little bit less time than I had initially hoped for, but I worked really hard on this presentation, so here's the first slide. Oh yeah. Thank you. Yeah, that actually did take me 20 minutes. I initially wanted to have the whole presentation like this, but I just, went with just Comic Sans. So I am Jimmie Rodgers. I am a full-time hacker and maker. I basically travel around most often with Mitch Altman and teach people to solder and make things. I have a number of open source electronic kits, and I've been teaching circuit bending and running workshops and classes for the past 3 years or so, and mostly in the Boston area. I ran an event called Noise Night for a while. Sorry about my voice. I've been talking pretty much for 2 days, so it's almost gone. So here is actually where I'm going to dump all of the information. If you have QR code, you can just snap a picture of that. There will be another slide at the end for questions, so you don't have to take the picture now if it's not available. But it'll just be on my website. I'll post the slides and everything. But yeah, so first off, what is circuit bending? It's just modifying toys, electronic instruments, radios even. Some of the first stuff was just playing and noticing that you could get interference off of a radio that was sitting in a metal drawer, just all kinds of weird things. It's essentially causing interference in a signal, shorting circuits, bending where the electricity is going to be going, and that changes what that's supposed to be doing. The person who is credited as being the first father of circuit bending is Ghazala, although he takes no claim to that title. He coined the term in the 60s for some radio and electronic experimental instruments that he was doing at the time. But there are 2 books that are incredibly useful to have if you are interested in creating electronic instruments in general and circuit bending in general. The first one that was more useful to me was Handmade Electronic Music. The second volume is out, and it has about 1 chapter on circuit bending, but all of the other chapters pertain to a lot of what I'm going to be covering very quickly in this talk, which is essentially how to change timing on circuits, how to filter it, how to change waveforms, all kinds of stuff, and it's extremely useful. Circuit Bending by Ghazala, he covers a lot of very specifics of instruments, as well as some of the generals and some of the tools and things, so it's also a good book to pick up if you are interested in it. So first off, some of the really common, simple, easy circuit bends. I guess I should show you. Most things, like the Staples Easy button here, you can at least get a timing pitch bend. So you can kind of slow it down, but also if you slow it down a lot, you get. And that's actually pretty common to find in most toys. If you're going to find a circuit bend, it's going to be like that, because most things that you're going to be playing with are just simple sample type things. But not everything relies on that circuit. Sometimes it's a voltage drain where you're actually decreasing the amount of power that's available for the circuit. So the way that the timing circuits work for these oftentimes is they want to make these things as cheap as possible. So a crystal is actually going to cost them 3 or 4 or 5 cents to have accurate timing. So they just use a simple capacitor and a resistor. So a capacitor is an electronic component that stores a charge. And in the case of these circuits, they're actually filling them up with electricity and then letting them drain. So it's kind of like one of those Japanese water fountains, you know. You see them in the gardens. They fill up with water, they empty out, and then they go donk. So that donk is maybe 1,000th of a second or 10,000th of a second or whatever the computer or the microcontroller in the toy is declaring as a period of time. But the thing that's nice is, even though you can't change really on the fly the size of that bucket, the size of the tube, or the size of the capacitor, you can change the rate of current that flows into that, both water and electricity. The analogy works both ways. So kind of like how you tighten the water faucet, you slow the current, you slow the rate that it changes, you slow the rate that the microcontroller makes it sound. So that's the kind of basis of timing circuits. You change resistance, you change the speed. But the thing that's really nice about resistance is everything is a resistor, just about. You are a resistor, photoresistors, potentiometers, everything. Voltage drain works in a similar way where it actually affects the same circuit because sort of like you're dropping water pressure all of a sudden. So it's going to move slower because there's less water pressure. Audio output is really, really good to add to your toys if you're going to use it for any kind of audio recording and things like that, and I'll go over some safe ways of doing that later. And a power switch. It's really important because oftentimes you can crash a toy, and you need a power switch to turn it on and off, or just a lot of toys, just they're always on, and that's kind of annoying because you throw it in a bag and just it suddenly starts singing, or weighs 60 pounds and tells you how easy it is to lift, which is completely a lie. So some more advanced bends, these are not always available in toys. If you have a really complex toy, you can add a patch bay here. So the patch bay actually lets me get to a couple of... So it allows me to, on the fly, change a couple of things. More advanced toys like Casio keyboards and things like that are well known, they use the patch bays for that. Having glitch and crash configurations. So a glitch is sort of like what was going on there with the easy button, where it kind of you bring the circuit to a point where it doesn't really like it at all, so it just freaks out and makes a lot of weird noises. So that's kind of glitching out. Crashing is actually as the circuit is just completely falling down. It will make some of the more interesting sounds as it kind of dies. Then you have to reset the switch. So changing out crystals, changing out things like that, you can change it dramatically, change the speed of the toy. Changing out capacitors, kind of the same way. You can change waveforms with that and a few other things. And some of the really advanced stuff is MIDI controllable, or addressing it through sequences. So there's a Furby youth choir out there that's pretty freaking hilarious. So it's a sequence-addressed series of Furbies. So unfortunately, due to the speed of this talk, I'm just not going to be able to show like all of these video clips and sound clips, but it's all on YouTube and things, and I'm going to put some stuff in the link up probably today or tomorrow. So what to look for when you're looking for something to circuit bend. Battery-powered is way preferable unless you really know what you're doing. So that being said, you need to kind of know what voltages you're working with the toy, because some toys you can absolutely kill them. I've heard a lot of people say, oh, circuit bending's easy, all you have to do is just touch a couple of wires around. And that's true for a lot of toys, but for things specifically like the Furby, where they have motors and things, they have a much higher current to driving the motors, that if you cross that 9-volt motor driving current over to the 3-volt voice circuit, it pops and it's dead. So, you know, the 3-volt and 4.5 volts, those are pretty safe to like just kind of poke around with some wires. At 6 volts, you should start using some potentiometers in series. I'll get to that later. And at 9 volts or more, you definitely need to have protection or you're going to kill your toy. If you don't care, that's fine, but some of the toys are really hard to come by. In this case, it's collector's items, so I wouldn't be able to get another one. So toys with kind of fun sound samples. Something that's neat about that is, first off, just something that you find that's interesting, something that says something interesting for you. But you really need to play with it and kind of see how it works, because there's a lot of things that are not very preferable. So like this easy button, if I hold it down, it does nothing. I let it go, it makes it sound. But if I keep pressing the button, it only ever plays that once. I can't get it to loop, I can't get it to repeat. There's kind of a refractory period of sorts for the toy. And that's not very pleasant. You have to go through external circuits to get it to loop. But other toys, that's kind of a much more preferable kind of situation. So if I either hold down the button, it'll repeat, or if I press it multiple times, I can get it to trigger multiple times. So that's really great for sequencers, or just alternately having a toy that can be on in the background. But they're oftentimes limited to very few exploits if there's nothing more to the toy than just making sounds. But that can oftentimes be worth it. So that easy button, even though I can only press it once, I can get some crazy sounds out of it, and I can ride that for like 2 minutes or more. And it's great for samples if you do any kind of digital sequencing on your computer, background noises and that kind of stuff. So toys with audio input are amazing. Kind of my favorite. There's like the Barbie karaoke machine, which is kind of hilarious because it has this echo effect in it that's just spectacular. But also in a lot of the toys take microphone inputs, and those are sometimes preamplified. So you can actually run a guitar through it straight without having to like actually amplify it. So in this case, I have run guitars through it, and I can use the patch bay to have kind of a modular guitar synthesizer and things like that, effects pedal that's pretty crazy. So I use my Atari Punk consoles oftentimes as a frequency oscillator. So yeah, it's really nice to have the audio input because you can tie the toys together. But look for ones with effects. Like if it has, in this case, it's changing your voice to sound like a robot or something like that. But if it has echo effects and delays and things like that, it's really great. So another thing that's really important is the age of the toy. I recently went to China and kind of purchased like all of the toys I could find, and my room is overflowing with toys. I just keep buying them or finding them in various areas. And now that I'm known to circuit bend, people just leave them for me. But what I find generally is the mid-'90s to the early 2000s are kind of the best. It's before they really perfected the chip-on-board thing. You've seen it if you've ever taken a circuit apart for like cheap manufactured goods. It's like that black epoxy blob. So they're actually making the circuit on top of the board, and that epoxy is there to protect the circuit. So in the early 2000s, that process really got more refined, but a lot of the factories hadn't been turned over, but now they have. And so now even like the cheap toys that you used to be able to actually do something with, they're like completely useless because not only do they have the timing circuit is underneath the chip on board, whereas previously it wasn't good enough to actually have the capacitors in there and some of the other stuff. But they have brownout protection for them now because parents don't want Tickle Me Elmo going as the batteries die. So yeah, so what ends up happening is as Elmo goes through puberty a little bit, it just eventually cuts off, and then it seems like it's dead, even though there's quite a bit of juice left. So those are things that you definitely need to like look out for in toys. The more sophisticated the toy and the newer the toy, the more likely you're going to run into those situations. That doesn't mean that it's completely unbendable, but you're going to run into a lot of problems along the way. But yeah, things to look out for is novelty. Like, wow, this thing speaks Esperanto, really? People actually do that? That's awesome. But does it have audio output? A lot of times keyboards and things like that have it, but occasionally you'll have these toys that put headphones on it, which amazes me. I guess parents like that because, you can just sit your kid in the corner and have them make sounds and it doesn't bother them. But does the case actually have rooms for circuit bending? I have this weird thing where I like the toys to be toys. So a lot of circuit benders take the components out and recase them and do really cool stuff, and there's nothing wrong with that at all. I've seen amazing artistic pieces done that way, but I actually prefer the toy aspect of it. And even the breakout box that I built for this one, this is the original toy, and then this is the breakout box. I tried to match the color and everything to the original toy as opposed to the other way around. But also how small, nice, and new is the toy, because the smaller it is, the smaller the components, and the less room you're going to actually have to work in that space, or the harder time you're going to have soldering to the components. So if you're not used to dealing with surface mount components, you're going to have a much more difficult bend in your hands. So where do I find toys? Usually secondhand stores, unless you live in a really, really retarded state like Massachusetts, because they passed this law where you have to test all toys for lead. But that also applies to secondhand stores. So essentially, like, they can't sell them anymore secondhand because they can't afford to test all the toys, so they get thrown away. So actually, I have friends who go dumpster diving all the time, and we go behind the Goodwill and get all the toys out of there. But flea markets are great because you can actually sit there and test the toys and play with them. Secondhand stores as well, they usually have the batteries in them, so you can play with them and see if that's what you want. And if anyone lives near Massachusetts or near Boston area, MIT has a flea market, and there's a few people who cater to circuit benders and bring toys and other things like that in there, and that's really awesome. But eBay, usually you can find stuff that just by looking at the toy, see if it's going to be something interesting. I have this little harp that is made for like a really, really young kid, and it's actually the cutest thing I've ever seen. I bought it for like $3 on eBay, and when you turn it on, it says "I love you." And I just actually haven't had a heart to like change it because the only bend I could find was just the kind of the timing circuit bend. But it's so cute. I just added the audio output, and I just use it as a sample unit. But after holiday sales are great. So specifically in the big box stores. So if you go to Target or whatever, like December 26th is the best day for circuit bending ever. Because just all of that crap is there. So some of the things that you're going to need, it's not terribly complicated, and you might actually already have it, but things for opening things, that's pretty important. Screwdrivers, unless you're doing high-tech toys, you don't need like hex or the torque screws or anything like that. But you do need a lot of patience if you don't want to break the things, because they oftentimes use those snap-to-fit kind of tabs, and that can be pretty annoying. Various resistors, so potentiometers of various sizes. I generally stick with linear because you get the gradual change. But in some cases, you might want to go with analog, which has a logarithmic scale. It depends on the toy. Alligator clips are really good because you're going to be using that to connect things for testing purposes. Wire of various sizes. I generally actually go with a 30-gauge Keenar wire unless I'm going with a structural thing. It's really thin wire. You can break it very easily, but it's great for snaking around things, and just a dab of hot glue, and you've got a bit of resistance so it doesn't break off so easily. Soldering iron, of course. The better soldering iron you have, the more easily you're going to be able to work with the smaller toys. Solder, go with the leaded stuff. The lead-free is really bad because it just takes more heat to get it to melt, and you're more likely to break connections and be more frustrated, so get the leaded stuff. A driller, drill press, I usually use a Dremel. Multimeter, but the best tool of all is my tapered hand reamer. I have 2 of them downstairs. You can see their majesty. Essentially use these things to get holes to fit. That's how I get everything in all of my cases to look exactly like they should have always have been there, because they're only as big enough as the part, because you just kind of like hand drill it out, and then you test the part, hand drill it out, test the part until it works. They're amazing. They're like $15, just get one. So now, how to kind of circuit bend. The first thing I like to do is just play with the toy. I mean, really, that's my excuse for it anyways. But yeah, just how does it respond? Like, test the buttons like I showed before. Are the sounds actually something you like? Do all of the buttons work? Do you need to do some work with it? I actually prefer toys that look like kids have played with it, so like buttons have like been rubbed off. So the first thing I sometimes have to do is fix the toy. So things like friendly plastic or thermal plastic, whatever you want to call it. It's really good for like breaking some of the broken off tabs and things like that. Can you get it to crash regardless of bending? So like a good example is the speak and spell. Like there's a couple button combinations that you can get it to freak out for like minutes at a time without ever actually opening the box. It's pretty cool. Then you just open up and explore it, but use your hands first. So the thing that's really important is you are a resistance, or you are a resistor, so you provide resistance to the circuit. So like when you're touching and making, shorting various points in the circuit, it's not likely to fry anything unless it's plugged into the wall, which you shouldn't be touching it anyways. But I usually have a beer or other cold beverage on hand and just kind of use condensation from that and touch around on the circuits. I wouldn't advise licking it because of some of the industrial things that they put on there. But looking for resistors gets you the really quick kind of circuit bends, kind of getting the timing changes, seeing if they're there. But take notes. Write down anything you see. Usually after 3 or 4 points, I start writing things down. Before that, you can kind of remember it. And when I find interesting things, I'll just put in some fresh leaded solder onto that point, and then solder in a bit of wire. That way I can clip in an alligator clip later. But yeah, so the way I then start exploring is an alligator clip with a 1 meg linear pot in series with it. So I have a clip in the middle, a clip on the side, and essentially it goes through that because I start touching around. And even at 1 meg, you'll hear like a little dip. It'll be like, and so like that's just enough that you know that that's a point that you should explore. And so then you just keep turning it down by a quarter or by a half until it does something interesting. But yeah, if it's, like I said, 3 volt, 4.5 volt, you can just kind of like keep reducing indefinitely. But if it's like a much higher voltage toy, you really want to watch out because you'll definitely pop something. But yeah, then start tying things to ground randomly. If this is a point that's interesting at this other point, then just bring it over to ground, see how it dips. Don't ever tie it to the positive voltage unless you really have protection in the way because you'll definitely fry something that way. But try random pins, just start touching around, just see what happens until you figure out what's going on with the circuit. And just because it stops making a sound doesn't mean it's dead. A lot of people, like the toy, you'll get it to crash and it'll make really cool sound, and then it doesn't do anything. Usually you just pull out the batteries, pop them back in. But also if you've removed any resistors or anything, make sure that you still have resistance to complete that circuit, because if it's not completed, it's not going to start, or if your resistance is too low, it might not actually start either. So reset switches are pretty useful because then you can just go toggle, toggle, and the toy starts working again. So tuning the resistance for the toy is actually a little bit complicated, but so once you're below that crash point, there's some point that you need some amount of resistance there for the circuit to start whatsoever. So some circuit benders that I know, like they don't like to put anything in series with their stuff, like they let it go into that crash zone and let it ride out, but I like my toys to start anytime regardless. So in the case of this easy button, I actually, at its lowest point, I press the button and it's actually going to take a while before it starts. But this is a comfortable setting for me. Yeah, so.
I see.
So what was going on there was the timing of the circuit was slowed down so much that it was taking, seconds to start. So I kind of found a zone that was comfortable where it was a range that it started in enough time that it wasn't too bad, but also I can explore that kind of zone even lower once it does start. So essentially you keep reducing resistance until it stops working, and then measure the multimeter, and then kind of pick a solid resistor to then put in series with it so that you don't drop below it. But yeah, once you start finding interesting things, take out the original resistor and just start exploring that circuit with what you found out previously, see if things change, see how it does. But there's kind of 3 main controls that you can use for changing that resistance. Potentiometers, as I said before, like generally it's a linear kind of movement. up or down for how you're changing the resistance and thereby changing the circuit, the timing of the circuit. But other fun things are photoresistors. So photoresistors kind of can give you a kind of theremin style effect. But that doesn't work in all lighting conditions. This is great because I have direct lighting and they're actually not fluorescent, because in the fluorescence, this thing, you hear the 60 hertz buzz and it's really annoying. So that's something you need to keep in mind with photoresistors. They can be awesome, but not always really reliable or controllable. Touch contacts are my favorite because you can learn them over time. So like learning any other instrument, you actually learn how to play your circuit bent toy. And I actually prefer to use these RCA jacks in a lot of my toys because you can get them in large patch panels. They're really cheap. Everybody has those RCA cables that you have from leftover VCRs and things like that. But also the metal quality is really high. So they make great touch contacts, but also you can break them off for, you can add that photoresistor later to those touch contacts, things like that. So you can make a modular system of other things. But you should decide based off of how the circuit performs, how it controls, because they all respond a little bit differently. Like I said before, you might need to put a resistor in series so that it doesn't drop below that. And basically pick a potentiometer off of what the controls you want are. So if you put a 1 meg potentiometer in, you might get like really slow, like where it's like, but that might not actually be useful to you. You might not want that. You might actually want it to be a sound sample. So you cut that into the 500K and it's suddenly like, and kind of a little bit more interesting. But the big potentiometers, you get big sweeping changes over time. And it's really hard to get direct controls unless it's a zone that just makes a really nice sound, because what might be only like 10 degrees of interesting, if you go to a smaller potentiometer, it's like 180 degrees of interesting zone that you can play with and get different sounds. But that always doesn't always matter. Sometimes I'll actually use 2 different potentiometers, one for the slow and one for the short interesting zone and one for the larger sweeping changes, but it depends. So audio out is important. It's really good to be able to bring out the sound samples and tie them into other toys. But you have to kind of be a little bit careful because if you wire up positive and negative in one toy, it's not going to really matter if you plug it into a stereo. It's going to auto-equalize because the ground is actually what it's referencing off of. But if you do that same thing and plug that into the input of another toy, they both might turn off. You might fry one or the other, so you need to kind of be careful about that. Just measure it with a potentiometer, see what's positive, see what's negative, and wire things together that way. Oftentimes, a lot of toys the signal is really hot. So what I mean is when you plug it into a sound system, you're actually going to see it like pegging it red the whole time, and that's not really good for getting any kind of coherent audio out of that or into a performance or anything. So the simplest way of doing this is just take a 10K potentiometer, have your signal coming in, one signal going out to your output and the other going to ground, and you have volume control in no time. You can level that off, and it's just one additional part. You don't have to like do any calculations on that. Also, cutoff jacks can be pretty interesting. So without a cutoff jack, if you tie straight to the speaker, you can actually use your speaker as a microphone. It's a poor microphone, but it's a microphone. Testing. Yeah, so it doesn't work so well, but you can usually get some sound out of it. Usually for the easy button, I don't bother with the cutoff jacks, but for other toys, you definitely do when you're having the audio output directly connected to what's going into your sound system, because you also pick up interference and other things like that. So audio input is awesome if it's present in the toy. There are a couple of toys out there that you can record things, play them back, and have them loop and do some fun things. Oftentimes they have a jack, not always. They'll sometimes have a microphone that's built into it. if they have a jack and the microphone's external and it's a toy that just has like a little cheap microphone, then it probably has a preamp, and that's really awesome because, like I said, you can plug a guitar into it and use that as an effects pedal, essentially. But they'll also kind of, it'll cut off some of the craziness that'll happen when you input some from other toys, some of the sound from other toys. But yeah, usually just if it has a mic, just add it across the microphone pins and you're good to go. Other times you'll have to tie it to one of the microphone pins and then the ground actually to ground because it'll be referencing off of a pin on the microcontroller, which isn't so good. Well, I mean, not if you want to bring input that isn't a microphone in, anyways. So some of the advanced stuff that is around. Yeah, these always take a lot more time. I call them advanced because they take more time, but it's usually a lot more exploration, to be honest. So the patch bays are for when you run into 50 points that are really awesome. So some of the keyboards, you'll see people with these huge, like 16 by 16 patch panel bays, and like they don't even know what this thing can do. Like there's only so many times you can explore it and so many combinations before it's just infinite almost. And this one, it's a 4x4, so I've learned pretty well what I can do with this one with a couple of alligator clips or things like that. But patch bays are awesome if you have a complex toy. And it also confuses other people, so it's kind of funny. So exploring with capacitors, kind of changing them out. So actually, if you get some various size ceramic disc capacitors, don't play around with the electrolytic unless you actually know what that means and know what you're doing with them. Because oftentimes the large, big capacitors in there can shock you when you touch them. Especially if it's something with a flash, like you can actually turn those things into stun guns. So just be careful with the large capacitors. So like the little ceramic disc ones are great, and just bridge them with other capacitors or bridge them with LEDs or things. Essentially, you're exploring like you are before, but now you're using additional components. It takes way more time, and I only do that when I find a toy that actually does interesting things when I'm exploring in the first place. Also, there's a lot of toys that have video output, especially nowadays. Plug into the TVs and things like that. Said karaoke machines. Those can be pretty fun, but you can get a lot of interesting video artifacts and things like that. Yeah, even opening up Game Boys and stuff, you can get some weird kind of video stuff by just touching around on circuits. So triggering button presses is kind of a key. So like in the case of this easy button, getting this to loop when you want it to loop is, for that toy, it's a non-trivial task. You need an external chip for oscillating a couple of things. But some you can get away with just a simple like transistor. So a transistor will read a signal and then either open or close a larger voltage or larger signal. So what you can oftentimes do is just tie the transistor to the speaker output, and if there's no kind of delay period between when the sound starts and when you press the button, you can actually get it to loop very quickly and easily. Because what will happen is when you flip the switch on, the transistor reads that the speaker isn't doing anything, so it opens the gate. So that makes the sound happen, which then turns the speaker on, which the transistor sees that there's now sound happening, so it closes the gate. And then as soon as the speaker turns off, there's no longer sound, so it opens the gate again. And that cycle will loop. But that doesn't really work for all of the toys. It doesn't work for the easy button. So what you'll have to do is get some kind of external oscillator. So either a 555 timer. I use Heck-Schmidt trigger inverters, which are, if you're really interested in it, I can talk to you later about it. It's just a really simple way of making a square wave. But also microcontrollers can do that. And essentially, you couple that with an opto-isolator. So an opto-isolator is a component that essentially has an LED and a photoresistor coupled in a very small package. So when you run a very small voltage across it, it will then drop entirely the voltage across the other two pins. So by tying what your positive voltage is across a button to the opto-isolator to turn that on, closes essentially the button and it acts as a button press. You can use relays for that as well, but relays are expensive and yeah, just not really necessary unless that's all you have. That's what Radio Shack has, so if that's what you got, then you can use them. But they also take quite a bit more amp hours, so that's it uses a bit more electricity essentially. So MIDI control is something that's extremely exciting about some of the really advanced circuit bending toys, because like I said before, you can have the opto isolators for remotely triggering button presses. So you can directly with a keyboard control the buttons that are being pressed on that toy. So if it's like a little guitar with buttons up the neck, you can map that to your keyboard, you can map that to your MIDI controller, you can map that to anything. But you can also, within the MIDI command structure, you can actually change what the pitch is for each of those commands. So they make these digital potentiometers that through a digital signal you can change what the resistance is that it's outputting. So you can actually change both the speed and the triggering of that by through these digital circuits. But also, if you have a microcontroller, you can generate square wave output, which you can actually replace the crystal for of the toy, and then you can, with a bit of work and a bit of coding, you can actually have your toy on beats per minute, which is really, really freaking cool. So you essentially have a completely controlled toy. And I pointed out Arduino on here because there's a MIDI library that's really nice. You have access to these, all of these commands are available, and it's pretty easy to program and get into. But there are a couple of other dedicated MIDI boards that are out there that you can look up that add them in fairly quickly and easily. So yeah, there's a lot of really great resources on the web that constantly have links to interesting things. Get Lo-Fi is a great website. They cover not only like circuit bending stuff that's going on around the world, like show really cool bends that people have posted to YouTube, but they also have like weekly like any free albums that are out there, because there's a lot of chiptune and circuit bent and all kinds of other electronic music stuff that's just given away for free, and that's wonderful part of the culture. Casper Electronics, he's actually here in New York, and he does a lot of very interesting bends and publishes very clear instructions online on like how to replicate those things. So the kind of interesting thing is anytime somebody finds a really cool circuit bend, you'll watch the eBay price of that thing go up from like $2 to like $50. So said Barbie karaoke machine, it's this kind of really cheesy pink plastic thing, wonderful in how completely horrific it is and what a girl would like. And you can get the most ridiculous sounds out of this thing because of some of the effects that they run your voice through. But circuitbending.com is a kind of interesting website that has links to examples and a couple of other things, a lot of pictures. It's sometimes hard to navigate, but there is a good bit of information there. And Bend Festival happens here in New York every year. So you can talk to other like-minded geeks and see how this is all done and share and trade, and people buy and sell toys and all kinds of stuff. So yeah, that's really awesome. So tomorrow at 1 o'clock in the Hardware Hacking Village, I'm going to be doing Circuit Bending the Easy Button. And it's $25, has all of the parts and access to my part bins. So one of the things about kind of getting into hardware and electronics is, honestly, I started buying potentiometers to support my own habit. So my friends joke that I'm a pot dealer. But yeah, it's kind of true. Like I have hundreds of pots of just all kinds of values and things like that. And my friends will literally come up, they're like, hey dude, I just need some stuff from you. But yeah, so you get access to all of those bends, and I will help you through exploring this. And like I showed before, you can get some pretty interesting sounds out of this thing. Register online if you're interested in it. Staples screwed me out of a bunch of easy buttons, so I had to run around Manhattan on Thursday and Friday, and I found 11. Apparently that's all Manhattan has, is 11 easy buttons. So bring your own easy button if you can find one outside of the Manhattan area, $20, and you get the same parts, photoresistors and all kinds of stuff.
Where's the URL?
Right there. So that's the QR code that will bring you to that Hope Talk thing. So right now, all there is the pre-registration, and also the link to my outline of some of the stuff that I mostly covered, and I'll put the slideshow up once I have it, and I'll throw some links up there at some point. But yeah, are there any questions? Yeah, there's microphones off to the. Yeah.
Have you played at all with routing the audio output jack into an audio input jack and producing feedback loops like that?
I have it built into some of my toys. So that's exactly what I'm doing here. It's just literally a switch that I toggle that on. So.
Is there a time delay in that circuit?
A little bit, but not so much. It really kind of turns the whole thing to garbage so much. If I talked through it, it's like for the robot voice, you can hardly understand what it's trying to say. But yeah, it really does digital stuff so well. And also, stick around or see me later. You can play with these toys. They're out and available for you to play with. But yeah, so.
I had a second question. You were talking about the video circuit bending. Have you worked at all with feeding audio input into video output?
I have not personally. Video is not one of my direct interests. Some of my friends do it, but yeah, I mostly like audio type things. And but dude, that would be probably hilarious and awesome.
I'll get on that then.
Yeah, please try it. Yeah. Yeah.
I was wondering if you could go into more detail about the Barbie karaoke machine. What did you do to bend that, and what kind of results did you get?
So, explaining that to my roommates. No, I'm doing something because this is my job. You know, I'm a full-time hacker. I have to play with toys for a living. So I gave it the bad touch is basically what it was. No, really that one, it's mostly to get at those delicious echo effects and delay effects. Because you can actually, there are a couple of points that you can change, essentially like the decay of the echo and all kinds of other things like that, through entirely analog means, like not purposeful whatsoever. But Peter from Casper Electronics really covered it quite well, and so that is not one that I explored personally. A lot of circuit benders really go for like the toy that people have never seen before, which is pretty cool. But a lot of other people just do what they have seen before, and that's fine. Okay. Yeah. So yeah. Any other questions or? Yeah.
So you've talked a lot about bending toys, especially simple toys. Do any of these things work on really complicated systems like game consoles?
Yes.
Old computers?
Yeah, and actually there's a whole subset of the chiptune scene that circuit bends a lot of things like the Get Lo-Fi guy. He actually sells a mod kit for the Game Boy so that you can change the timing of the Game Boy. And the whole MIDI control aspect of it really ups the game a lot because that's a highly technical kind of thing that you're doing. Yeah, some of the early stuff was actually modifying like synthesizers and keyboards and things like that. So the Casio SK1 is a really well-known keyboard, and that's where that 16 by 16 patch panel bay has come from, because there really are that many points that you can tie into, and I don't think people have still explored fully what that instrument can do, and it's pretty crazy stuff. So yeah.
Cool.
Yeah.
Okay, this is maybe a bit specific, but I'm in the fandom for the BBC TV series Doctor Who.
Okay.
And there is one specific toy that came out, some months or maybe a year or two ago, which was basically a remote control toy that was actually voice controlled. Do you know if anyone has tried to bend that?
I haven't seen that directly, but like I said, like some of the problems with the really modern toys is they're so sophisticated and trying to protect you from messing it up that you can't get out a lot of the stuff. So oftentimes, if you open something up and you see that black blob, and all you see coming out of it is like speakers and the batteries coming in, and maybe the button, like just close it. You know, you're not going to find anything there. But depending on how complicated the toy is, I don't know. I haven't seen it specifically, but if you have one, we can give it the bad touch, so to say.
Right. Unfortunately, I don't own one, but I know someone who does.
Well, then open it up. All right, I've got about 7 or 8 more minutes. Any other questions or? Nope.
You went over the Barbie karaoke and the speak and spell. What are some other, I guess, like really infamous toys that have been bent?
The Furby pops up a lot because they're kind of creepy to begin with, and when you skin them, like it's just it's kind of hilarious. But yeah, those have only a few points you can do, but like they've definitely been sequenced and other things like that. But yeah, there's a number of keyboards that are well known to be ripe for bending and things like that. That Circuitbending.com website covers a lot of the really popular things that's out there. But actually, the entire Speak series, there's Speak and Math, and what is the other? I'm sorry? Oh yeah, the Speak and Read. They all use the same kind of TI voice chip, and they're all really, really good for getting some crazy sounds out of. But yeah.
Teddy Ruxpin, have you, besides sound bending, have you heard of anything to deal with the mechanism? He's very articulate.
Yeah, a little. He doesn't do too much. That's my cell phone receiving data and my speaker being on. Which actually GSM interference is kind of fun to play with too. I'll sometimes go to websites just to get that interference. But anyways, so Teddy Ruxpin specifically is entirely mechanical, and he just plays a tape, and that is directly translated into mechanical movement into the jaw. But there are some really, really weird ones out there like Yano. Nobody in this room should know what it is because it is the creepiest toy I ever had. I saw it at the MIT Flea, and I have this rule where I don't pay more than like $5 to $10 on toys. Otherwise, like when I go to the circuit bending swap meets and things like that, like when these $50 crazy things show up, like I would buy all of them. But Yano showed up and he was $25, and I was just like, this is the most uncanny valley disturbing thing. And he's a storyteller, but he has these full facial features and controls and things like that. Yeah, so there are toys out there that you can get these weird animatronic aspects to it, but like I said before, usually the motor circuits and the voice control circuits are very, very different voltages, like dramatically different voltages. And you have to identify which is which. They're usually separate circuit boards, so that makes it a little bit easier. But you just have to be very careful when you're exploring those toys. Always have potentiometers in series with what you're exploring with. Even if it's on what is obviously the voice control board, still explore with protection there, because the Furby you can kill in about half of a second, because it's all on kind of the same circuit board. But yeah.
What about Tickle Me Elmo?
I haven't actually played with the Tickle Me Elmo, but I think it's entirely just electrical, and there's like a little vibration sensor or vibration motor in there, but it's probably the same deal. But yeah, I haven't seen any of those bent, but I'm sure that I would get a letter from somebody. Anyways.
I was wondering, you said that someone was mentioning that some products now have like goo in it, so you can't take it with certain parts.
Yeah, they put epoxy on top of it. Yeah.
Is that, I mean, I don't know if you've seen like much older toys or recent toys or other things that have this. Is this like something that people are now putting in more and more, or is it just
Well,
random?
it's because the manufacturing process got a lot cheaper. So it's kind of the same way that they do integrated circuits and like your processors. So you might have seen those pictures of like the Pentium chips where there's just thousands of processors on this big, huge circle, and some percentage of them are just going to fail, but they know that percentage, and then they just cut them out. So they actually manufacture that on there, and then they just put the epoxy on top of it. So it's a very quick way of kind of being able to do this with essentially lithography is how they're building this stuff up.
Aren't those really high volume?
Not anymore. They'll do it for as few as 1,000 or less. Miracle of China. Like, you know, something doesn't exist, you send them an email, and the next day, yeah, we got lots of those. You know, it's just... But yeah, that manufacturing really started getting a lot cheaper in the past few years, and especially recently, because a lot more factories are capable of doing it now. And yeah, so that's why the future of circuit bending is nigh. But there's still tons and tons of mid-90s to mid-2000 toys that are really, really good for kind of stuff. But
Have you seen any bends on this the storytelling Barney? You actually download there's something that looks like a RJ45 jack.
Mhm.
It's connected to a serial put on a computer, and you have to go on their website and download some stories and then download it to the
no, I haven't seen anything specific to that, but that sounds like it's ripe for hacking, period. Because usually you can reverse engineer those protocols for a couple of things and get data out of them. Like there's this Star Wars kind of mind control Jedi thing. It actually talks RS-232, so you just hack into the thing, and just with you know, any kind of serial port, you're suddenly getting like really, really, really low level like brainwave kind of stuff. But yeah, I mean, that's the kind of thing that I wouldn't even like circuit bend first. I would see like what I could sniff off of it and see what I could get it to do and say regardless. Yeah. Anything else? Yes.
Sorry, can you say more about the Star Wars thing since I actually have one of those?
Oh yeah. You're just gonna have to Google online because there's like 4 or 5 pins that you need to solder to, and if you have an FTDI cable or chip, that makes it really, really, really simple. But essentially, you're breaking off TX and RX, and it's simple RS-232 serial, which is the same thing that's in the back of a lot of desktop computers. No laptops have those anymore. But yeah, just with the serial communication protocol, you can actually you just get raw data from 3 different values of like what it's. I forgot what it is, like how strong the signal is, what the signal integrity is, and then like what this actual signal is, you know, how high or low it is. But it's pretty cool. You can see it online. Somebody has a couple of programs you can download to see graphing information. And then you hook your friend up to them, and then you slap them and watch it spike, and it's pretty funny. And then the next time you just fake it, and then it still spikes, and it's even funnier. So. All right, anything else? Okay, so that's circuit bending. If you got any questions, I'll be down in the hardware hacking area. You are absolutely free to attend, just hanging out in the circuit bending thing, watching people bend the easy buttons if you didn't get to the registration in time to get one. But also bring any other toys you have, because I really do have parts, and I'm just going to, you know, encourage people to explore and play. Because circuit bending, even though I have a bit of electrical knowledge that helps me get into this easier, you don't have to have that to get into it. And the whole key here is to have fun and explore. And yeah, that's it. So